In this video, we will discuss the Infrastructure as a Service model in more detail. Infrastructure as a Service, commonly referred to as IaaS or simply IaaS, is a form of cloud computing that delivers fundamental compute, network, and storage resources to consumers on demand over the internet on a pay-as-you-go basis. The cloud provider hosts the infrastructure components traditionally present in an on-premises data center as well as the virtualization or hypervisor layer. In an IaaS cloud environment, customers can create or provision virtual machines, or VMs, in their choice of region and zone available from the cloud provider. These VMs typically come pre-installed the customer's choice of operating system. The customers can then deploy middleware, install applications, and run workloads on these VMs. They can also create storage for their workloads and backups. Cloud providers often provide customers the ability to track and monitor the performance and usage of their cloud services and manage disaster recovery. Let's look at the key components of cloud infrastructure. Physical data centers. IaaS providers manage large data centers that contain the physical machines required to power the various layers of abstraction on top of them. In most IaaS models, end users do not interact directly with the physical infrastructure, but experience it as a service provided to them. Compute. IaaS providers manage the hypervisors, and end users programmatically provision virtual instances with desired amounts of compute, memory, and storage resources. Cloud compute typically comes with supporting services like auto-scaling and load balancing that provide scalability and high performance. Network. Users get access to networking resources on the cloud through virtualization or programmatically through APIs. Storage. There are three types of cloud data storage: object, file, and block storage. Object storage is the most common mode of storage in the cloud, given that it is highly distributed and resilient. IaaS supports a wide array of use cases. We'll look at some typical use cases here. Organizations today are using cloud infrastructure services to enable their teams to set up test and development environments faster, helping create new applications more quickly. By abstracting the low-level components, cloud infrastructure is helping developers focus more on business logic than infrastructure management. Business continuity and disaster recovery require a significant amount of technology and staff investments. IaaS is helping organizations reduce this cost and make applications and data accessible as usual during a disaster or outage. Organizations are using cloud infrastructure to deploy their web applications faster and also scale infrastructure up and down as demand fluctuates. Organizations are leveraging the high-performance computing capabilities of cloud infrastructure to solve complex problems involving millions of variables and calculations, such as climate and weather predictions and financial modeling. Mining massive data sets to locate valuable patterns, trends, and associations requires a huge amount of processing power. Cloud infrastructure not only provides the required high-performance computing, but also makes it economically viable. While there are some concerns regarding the lack of transparency in the cloud infrastructure's configuration and management, and dependency on a third party for workload availability and performance, infrastructure as a service is the fastest growing cloud model today. In the next video, we will look at platform as a service model, its features, benefits, and some use cases.